G'day folks, time to have a look at an inverter, and as you probably gathered from the title, pretty obvious what this is going to be. It's going to be a Projecta. So why did I choose that? Or more the point, what size inverter do you need, I guess. Now I had an inverter, I put this in when I first got the caravan. We had no 240, and I had this thing. This is old school pure Sinewave 300 watt inverter. And it's heavy because it's got transformers in it. It's got lots of discrete components in it. And when they built these back in the early 2000s, there wasn't a lot of high-powered inverters around, and they were very much limited to how much power they could provide beyond what their continuous rating was. So 300 watts, yes, you can do theoretically a 600 watt surge current, but I found that this thing, it struggles to do that. It certainly won't run a fridge or anything like that. Motor driven devices or anything, it won't do it, but it'll run laptops, it'll run chargers and stuff. That's good. So we had that in, but my aim now is to use the caravan with quite a substantial power system on board. There's 220 amp hours of battery, which is absolutely fine for everything we want to do. I don't need a massive power station. I haven't got a lithium ion. I've got 220 amp hours of lead acids, and we've lived in this for 3 months. Works fine. So here we've got a nice big power system sitting in the driveway at 12 volts. That can support the house during a power outage. And when I say the house, I mean the fridge. The one thing you can't do anything about during a power out is run your bloody fridge, because you've got to have mains power for it. And the one thing you're going to have one of the greatest losses on during a power outage is your food. And particularly here, we're in Brisbane, we're in the subtropics, all our storms come through in summer when it's hot. And you know, you can't have your fridge off for long. It's got to be maintained. So yes, I could get a generator, and I've got a generator. I don't want to run a generator at night. And I've got basically a big solid state generator here. That's the new thing too now, is a virtual generator, which is a big battery with an inverter in it. Well, that's what the caravan can be. So dual purpose. I've got a power system in the van for when we're away. I can provide 240 volts, and I can support the house during these weather events, which apparently we're going to get a lot more of because of climate change. And certainly we're getting more violent storms, and we lose power across multiple suburbs here. You know, we had big storms the other night and we lost 40,000-50,000 houses without power for several hours. So I can run my fridges from the caravan. Don't need it for doing anything else. We've got headlamps, we've got gas barbecues, you know, we can prepare meals, we can get along just fine as long as the fridge keeps going. It's minimal impact. So that's what I wanted to achieve. And that's why I've decided on this thing. I'm not running big power devices. I know some people do for their vans. They have 3 and 5 kilowatt models. This is a compromise. This does what I need it to do. And you know, you switch on a 3 to 5 kilowatt inverter, it's going to sit there doing nothing, drawing 2 or 3 amps out of your batteries. This one will draw about 800 mils, 900 mils, I think that's it. And that's big enough. So you wouldn't want to leave it switched on for great lengthy periods, you know, days on end or anything. But this will do it. 1000 watts, 2000 watts peak. So that's fine. Let's have a look at this thing. I'll do an unboxing and testing. Oh, another point. This unit is designed to Australian standards. So when I plug my fridge into it, I know that this has to conform to Australian electrical standards. It's double insulated, but I know it's been done properly. I don't know what I'm buying when I buy a Chinese thing off eBay, because there is no standard specified that they were built to. So how safe is your nice big stainless steel fridge when you plug into a Chinese thing? I know this one's going to be okay. I know it's got good protection safety systems on it to protect itself against overloads, temperature, etc. So it fits the bill, it will do the job, I think, but let's find out. So I'm going to do an unboxing, do some testing on the bench, a bit of basic testing. Then when it's installed and it's connected up, we can do some real testing to see how she goes and whether it'll do what it says it does, which I'm sure it will. Let's have a look at the Projecta 1000 watt inverter. Okay, have I even got this thing to a point where I can open it? Probably not. Beautifully boxed, as you can see. So what do we got? We've got a very large box. There's the beastie. So let's have a look at that. Again, nice big fan. And you'll notice, no mucking around, that thing's got serious bolts on the back of it. Now you see a lot of these cheapy that rate themselves at these sort of power levels, they have crappy little studs on them that typically are largely plastic. And this part at the back here, it's relying entirely on the nut to make contact. And at the sort of current these things going to draw, it's just a bit inadequate, you know. It really is. So here you can see we've got a nice big solid, what's that, probably 10, oh no, it's not 10 mil, what is it? It is, yeah, it's pretty much a 10 mil stud for your power connections. Let's have a look at that. Yep, 9.5 mil thereabouts. Probably 10. Yep, 10 mil. Okay, so nice substantial stud mount for your power to come in on. Really good. And very important because what are we going to draw out of this thing? 2000 watts peak, you're looking at 100 amps or so, easy. I don't know. Get a book, of course. So this is the biggest one. You get one, these that come in 150, 300, 600 and 1000. So they're the continuous rated power levels. This is a Sinewave inverter, so you can run everything on it. No good mucking around with these modified Sinewave things, they're bloody awful. I don't know if it tells you anywhere in here how much power this thing draws fully loaded, but it would be, well, there we go. 75 amp hour battery. No, it doesn't. So around, they're saying 75 to 250 amp hour battery to run one of these, and that'd be right because it's just going to cave in. Alright, so at 1000 watts, 4 amps at 240 volts, what they're saying. But yeah, it doesn't tell us what that maximum power draw is, I don't think. Input current DC amps on 1000, yeah, 100 amps, okay. So 100 amps. That's going to need seriously large cables to operate that. So as with the AC charger, there is a remote here. And the telephone cable, again, great idea. Available everywhere, standard telephone extension lead. You can buy them in Big W, Kmart, Woolworths, JCar, hardware stores, readily available everywhere. And this only has to be a 15mm hole through a panel to mount that up. Not sure what the mounting arrangement is for this thing. It's a good question, isn't it? It's got some little notches just here and here, so I'm guessing, oh no, there we go, there is it. Maybe this pops off. Ah, this pops out. Okay, that's just a surround. Alright. Yeah, this has got little clippy things here, and that must be... Is it? I don't know. I'm going to have to read the book guide for big. Alright. So that's the remote control head that mounts up somewhere else. So as I say, if I want to, that'll be 4.5 metres. If I want to extend it, that's easy. I'll buy another one of these. That's longer, because no, that one's a captive plug. Okay, so you'd have to buy a. You can get a joiner for these. They're readily available. You buy that, it's just female to female, and you can just join two lengths of this together. So that would need a joiner to extend this. So that's the beastie. How long is this thing? This is 330 millimeters long, so quite high. What is it? Looking at 80 millimeters overall height. Obviously going to be nearly 180 wide, I guess, 170, and about 340 overall length. 310, 20, 30, yeah, about 340. So she's a big bruiser. Don't know what it weighs, probably a couple of kilos. It's about 5 pounds, something of that order. So, as I say, good fan on it for 60 millimeters. Okay, so it's a 60 millimeter fan, which starts on demand. So on the back here, we've got a chassis ground connection. If you require it, there's the remote port where the remote head plugs in. And as I say, two very substantial 10 millimeter stud mounts for the power. What else we got in here? Oh, okay, here we go. So that's just dress stuff. This mounts into here. Okay, so that's around. This is just to allow room for the screw head to make that a flush fit. So you put two screws into there, which I guess they've provided here. Yep. And then this is just a dress that goes around that, so that all pops together like that. Same as in the AC voice, and that will just clip in. So, yep, great. That works great. So you have to cut this square out. No, you don't. No, you don't. You just put long screws in. Yeah. Well, you can cut it out, I guess, but you don't need to, because that will all flush mount like that. So you just have screws that. Are they long enough to do that? That's a good question. No, they're not. Okay. You need longer screws if you're going to do that. But anyway, that mounts up like that. Now he's done it, hasn't he? He's clipped the bloody thing in. No. Okay, so that's going to mount up like that onto the wall. You need screws that will have to go, what, about, that's 20 millimeters. So you need about 35 millimeter screws, probably 4 gauge or something, that go through there and into the panel behind it. 15 millimeter hole in the middle for the wire to go through, and she all just pops together like that. So then you've got the usual. We'll have a look at that when it's installed and operational. So there you go, the unboxing of the Projecta 1000 watt, part number IP1000. Nice piece of kit, and you know, well built, nice and solid, robust piece of gear. It is heavy, and will work the way it's supposed to, I'm sure. Now I've got to do is find somewhere to mount the damn thing close to the battery. So we've also got here a couple of very substantial 10 millimeter battery cables. And then we lost a bit of power there for a short period. Yeah, so I guess they're about a metre long, maybe. Quite warm here today. It's about 30 degrees Celsius. We're getting not even into summer yet, technically, so good old climate change. We're really copping it. Yeah, that's probably. Yeah, that's so. These are 1 metre long, and I'm going to have to put some sort of circuit breaker arrangement onto those. It'll take 100 amps. So I've ordered a 100 amp breaker in, but I probably should get something bigger than that. Probably should get 150. Might have to do that. Anyway, for the moment, that's going in, and I will not be going through the current shunt for this beastie, because it's only rated to 100 in total, and I don't think there's any point. This just needs to go. I don't want any further resistance in the way. I just want this thing to run directly off the batteries. So as I say, you buy a lot of these and they have pretty pathetic cables that run off them. So here we've got very good substantial cables to go to the batteries, and that'll just drop straight onto the battery terminals. So it's all good. Alright, well that was a bit of an unboxing episode, and we'll see how we go from there. Alright, I just thought, well, I've got this here, give this a bit of a test run on the bench. So, as I said, very substantial bolts on here, 17mm spanner to do them up. I'm going to have to think about that when I install it, about how leave enough room for these spring washers too, to make sure it doesn't come off. Alright, that's not going anywhere. And this is what I mean about these. This is the sort of stud you get on a lot of the inverters. They're just hopelessly inadequate, and they just have a knob, a very small shaft. That's only probably 5mm. Very small knob, and you'll see it's relying entirely on either just this back connection, and that's quite a small platform for that to get it, certainly at the sort of current ratings we're talking about. That's just completely inadequate. Probably can't see that very good, but anyway, let's have a look and zoom in. So you can see there that they're fairly inadequate. It just doesn't fit very well, and no metal contact to speak of there. I mean, that's going to completely miss that. So you wouldn't want to be drawing 100 amps through that. But anyway, for the purpose of this exercise, that's exactly what I'm going to be doing, but I won't be pulling that much current through there. Okay. Well, I'll just try and get this on. This power supply is a 40 amp, and I'll just do this up and then I'll come back. So the problem with these two is, on these little cheapies, you can't do these knobs up. If you try and do that up with a pair of pliers, the knob will come off the brass insert and it'll just turn around. Equally, on here, let me get the thing in the frame here. Equally on here, you can't turn those down either. You can't over tighten those. I've just done those up with a lot of pressure, because in a lot of circumstances this stud just goes straight through the casing onto the PC board, and as you go to tighten it up, it'll rip it off. So as you can see here, I'm going to have to allow for that when I mount. You probably can't see because I haven't got it down low enough, but I was saying I'm going to have to allow for that. Okay, down the wrong spot again. Okay, as I said, I can't. I've really got to come out sideways. I can't go this way. I don't want to go across the fan. I guess I could, and I can't go down because that's going to stick down lower than the mount hole. So this side's pretty clear, but again, I can't go down. I can either go out sideways. I can go across here. Chassis grounds, I think if you have extended runs on this, it's sometimes beneficial to give you, so you get no potential difference for the electronics, which is what that's for. You take that to chassis ground and it gives you a second path back to the battery via the chassis. So anyway, there we go. That's in and all tightened up. So let's just have a look at that then. We'll turn that on. Oh no, wait, I'll turn the power supply on. Bring it up to 13 volts. So we've got our power supply on now at 13. I guess 13.8 is the typical voltage for this sort of stuff. So there we go. closer look at the front. Turn this on, so we're all correct. Positive and negative, positive and negative. Double check. And there we go, she's away. As you see, it comes up to, says I've got 13.8 in. And you'll notice up here, it's telling me I'm drawing about 0.8 of an amp. 800 milliamps is its draw with nothing happening, which I think is pretty much on spec. Yeah, so pretty much plugging anything in is going to, let's have a look, I'll just find something. Okay, I've plugged in a bench soldering iron here, which is just this thing over here. This is only drawing, I don't know, I guess it's maybe 100 watts. I don't even know if it's that. But you'll see, yeah, it must be. This thing's drawing 9.5 amps. Now, what does this tell you down here? Let's have a look. Tells you watts. Oh, well, there we go. 83 watts. So it gives us watts. Gives us a percentage of load. It's 0.08%. Yeah, that'd be right. 83 watts. So 1,000 watts. Yeah. What's it done now? It's cycled off. Yeah. Okay. So the iron's come up to temperature. I'll just kick it in again. 83 watts while the soldering iron's on. So there we go. So what it doesn't do is tell you amps, which is interesting. Just tells you watts. But I guess that's all you want to know on an inverter, is how many watts it draws. Anyway, I just tried a shop vac on it, a 1400 watt shop vac. It started and immediately tripped out because this power supply is only 40 amps, and it rattled off up to about 45 amps and then gave up. It went into overload. Okay, I've plugged the caravan charger AC in now. So you can see it's at 20% load. 200 watts, because I've turned the fridge on, so the 240 volt section of the fridge is running, so running at 197 watts, and that's drawing 19 amps. So there's considerable amounts of power required to run stuff. I wonder what happens if I turn the fridge off and the air conditioner on. Let me just try that. Well, no, afraid not. That tripped out the power supply again, not this. It overloaded the power supply because it was more than 40 amps. That's the caravan air conditioner. There we go, she's back again, so it just went into a trip out mode. So, got a 10%, 67 watts. So that's with it going. I don't think anything much is turned on. So we've got 62 watts of power there, and off the power supply that is 7.3 amps. Anyway, here we go. We'll go and get it installed. Okay. I've installed the inverter into the caravan now. That necessitated a rewiring because I simply ran out of battery post. I had too many connections going to the battery post. So I decided I'd bring some of the accessory equipment and move that back inside the van rather than in the battery box. It's too hard to get to in there too, and it's very difficult if you're trying to connect up leads, especially with the inverter cable, trying to put a bolt through that and make it go where you want to when it's 10mm cable. It's very difficult, and trying to line up all the eyelets when you've only got a little bit of space to move. So I've rationalised all that. Alright, let's have a bit of a look and see what we did. Okay, so down here is the inverter outlet, which I've just marked up as that. There's two outlets on it. I've plugged in this yellow lead at the moment, and shortly I'm going to do a little bit of a test with the microwave, which I don't think it's going to run, quite frankly. I really don't. But anyway, we'll try that in a minute. So down here under the bed, which is where I've got all my power stuff, particularly all my projector stuff, it's all mounted down here. So that's the AC mains charger at the top. Down the bottom is the DC to DC, IDC 25. The top one's the IC 2500 25 amp AC mains charger, and down here is where I mounted the inverter, and I haven't tidied up the cabling at the back, but you can see the positive and negative going through that wall, and just on the other side of that wall is the batteries. This is a battery box. Then all this stuff's mounted on here. It's where the batteries are. Wasn't happy with the mount, a single hole mount on this thing, so you should be able to see that I've actually put in nuts and bolts down there, 2 nuts and bolts, and front and back, and I'll put those 2 pieces of wood in here onto the wooden frame to hold it, and it's very substantial. It's fine. In front here I've added a RCD. A little concerned about this. There's no earth reference off these. The active and neutral float, basically. There's no. It's different to a house wiring situation, and so this is a bit of a compromise method of safety. I guess it's not super ideal, but it works. And so that's in line. That's just a plug-in thing. I got that from JCar, and which I think were $30 or something like that. And then into that I've got a I've plugged in a cable which runs around the van here in this grey conduit, goes under the floor, and appears at that power point I showed you. Okay, time for some real-time testing on the inverter. It's all installed, as you know, so let's see what she'll do. So I'm going to try a couple of things today. One's the Sharp microwave, which I've got in the van, and it'll probably start it, but I don't think it'll run it because it's well over a kilowatt. And then a domestic fridge, which is one of the reasons I'd like to have a big inverter, as I mentioned, is to be able to run a fridge in the house as a stopgap in case we get a power outage just for a couple of hours or something like that. Oh, you want to run it at night when you don't want to be running a generator because it's noisy, you know, just to see you through that power outage sort of thing. So let's see how it goes. Alright, let's just start with the microwave. Here we go. Okay, here's our microwave. So we've got I'll just put some water in there. It's not going to go long, so I'm not worried about it being a plastic tub. So our microwave is rated to 1.22 kilowatts. You can probably see here if this thing ever focuses. Yep, 1.22 kilowatts at 240 volts. So it's a 800 watts, but obviously there's overheads involved in running that. So let's see how she goes. We're plugged in. Got the grey cord here from the inverter output. I'm going to turn that on. We should see some power. Stand by. I've just got to go check that the RCD hasn't tripped out. And of course it had tripped out, so here we go. Alright, so microwave's ready to go. If I just hit start, it'll go to flat out. I wonder if I try different power levels. I might try that next. Okay, this is going to be flat out test. Here we go. And hang on. Let's just get our meter here so we can quickly see how this is going. Here's our watt meter. Right, we've got 13.6 volts of DC. No watts. Okay, here we go. Ready and start. Oh, no, hang on, stop first. Okay, then start. 1.5 kilowatts. Well, they're a bit underestimated, but she's doing it. But she's going to trip out. There you go, tripped out. Okay, protection worked, tripped out. So I've just turned it off. Turn it back on again. No doubt I'll have to reset the RCD because that will have tripped, so stand by. Okay, certainly did. Yeah, so that RCD does trip out, so, but while it's a pest, I guess it's not the norm, so I'm not going to normally plug in something that's as big as this. Alright, next test. I've also got a shop vac, but I don't think this is going to work either, so I've got my shop vac here, which is 1400 and something watts, that's from memory. I'll turn that off, plug the shop vac in. Should trip, there she goes. No, it's holding it. Doesn't like it. I'll turn it off. Next test is this yellow cable here goes into the fridge inside, so let's have a look at that. Okay, here's the other end of our yellow extension cable, and here we have a Westinghouse fridge freezer, 1.5 amps at so what's it rated at? 450 watts. Oh, defrost. Yeah, okay. Because when these things defrost, there's actually a heater that comes on to defrost the freezer section. So we'll see what this runs out to. Power, I didn't turn it on. Okay, I'll just quickly go back and turn it on. Okay, here she comes. 140 watts, so that's in the non-defrost mode. Let's have a look here. Here we go, fridge is running. No props. It did it. Okay. On to the next test. Okay, let's try an induction cooktop. Alright, we'll turn this on. Okay, so I've set it to 80 degrees Celsius now. So it's just going to sit there at, I don't know how it figures that out, but anyway. There it is running at 980 watts, which is 99% of rated capacity of the kilowatts, 1 kilowatt. So it's at 98%, which would be right, because it's 980, 990 if you like. So she chuffs along and no worries doing the 1 kilowatt. That's no problems. Okay, well, I wasn't going to do this and I thought, well, because it's a bit of a pain unplugging the fridge or pulling the fridge out from the wall to do this test, but anyway, I thought I'll do it. That's a bit blurry, but anyway, there we go. Got the old yellow heavy duty extension lead out again. Here's the side-by-side Westinghouse. This is the big bruiser, and I guess this is the most important fridge to have working. Currently not on, so okay, let's have a look here. Total watts, does it tell me? Trying to read this upside down. 413 in defrost mode. So this is probably no bigger compressor, even though it's a side-by-side, than the previous fridge I just tested. So anyway, we'll just see how she goes, because this is, let's say, side-by-side fridge freezer. Alright. Okay, ready to go. Put our meter on watts. Put it down on the floor so we can see it. We'll just see what this kick-in current, if it measures it. There she goes. Well, see it whipped right up over a kilowatt just for a second, and settled into about 150 watts again. So very similar to the other fridge, and I suspect the compressor is probably similarly sized, even though it's a physically bigger fridge. It's essentially the same compressor in a lot of these fridges. Somebody told me there's only about 2 compressor manufacturers left now. So doesn't matter what brand of fridge or how much you pay for it, you're only going to get typically two compressor manufacturers. So you're going to get one of them. But anyway, they just run longer in a bigger fridge, I think. So 150 watts, piece of cake. No problems at all. Alright, well I think that'll do me for the test for the moment. I've done all that. Alright, so in summary, Projecta works well. As you saw, it hit peaks of, with the induction cooktop, over 2 kilowatts. Kicked up on there briefly. So it certainly will do that 2000 watts peak. It will hold the 1.5 kilowatts long enough for something that would start up and then pull back to a kilowatt or less. It will do that because we saw it do that with the microwave. We saw it do that with the vacuum. Well, when I tested the vacuum cleaner, I'm not sure I've got that in this video. But again, at 1.5 kilowatts, and it ran that for a few seconds before it shut down. So it gives it time to just to see if it's a peak load. But if it continues to do it for more than about 5 seconds, in excess of, you know, the kilowatt, it will say, okay, that's no longer a kick-in current, that's a sustained current, and I'm not going to do it. So anyway, good. No worries. Does it at a kilowatt. I've left it running the fridge upstairs there, so I'll leave that on for a little bit, I think, now, and see how it goes. So yeah, once again, I think Projecta has proven to be a good product. I've got no concerns about its ability to sustain the loads, to do what it's supposed to do, and not cook itself and not melt, which, you know, is possible with an inverter drawing the sort of currents. 1.5 kilowatts is we have 130 amps or something, 50 amps perhaps, I don't know. It's a lot of current. So yeah, so it's doing everything it's supposed to do. So happy with that. Happy with the fact that it runs my fridges. I could actually run both fridges, providing they didn't try and start at the same time. As you can see, 150 watts per fridge. You would, even the old one in theory, but I tried that even with a bar fridge, which has got still a similar size compressor, a small 140 litre bar fridge. You can't run that from a little 300 or 400 watt because of that kick-in current as that piston tries to start and pressure up the compressor. So you do need something with this sort of capacity, 1000 watts continuous, 2000 watts peak. Absolutely need that to run fridges. But having said that, I could run both of these fridges would only be drawing 300 watts running. I just have to stagger them starting up so they didn't try and start at the same time. But even if they stop, they wait 2 minutes and then start again, and I'm sure it would kick in after that. That's not a big, 150 watts is not a big push. That's about, what, 10, 15 amps maybe. And that would run for a few minutes and cut out. So your average current draw out of your caravan batteries is not huge. You could run your fridges for quite a few hours if you had a power outage. And that's exactly what my objective is with this, is to be able to do that. So yeah, fulfills that need well, and doing what I want to be able to do in the caravan, piece of cake. Ideal for the job. Works well. Thoroughly recommend it. I'll put a link where I got that from, somewhere on eBay. It was a really good price. So yeah, and there we go. Please like and put any comments on there. If you want me to check something else on it, I'll do that. I just thought I'd do some basic testing. So anyway, let me know. Thanks for watching. Bye.